Hi, welcome to our first Saturday session. So this is going to be what we're going to do once a month, where we meet kind of like on an off day, where you have a little bit of extra time, and unfortunately, we need that extra time to make sure we get through everything that we need to in AP Calculus. So today is actually pretty chill. I'm hoping this is going to be a shorter video, but we're going to be looking at graphs and what their behaviors are, particularly because the limits that we're going to look at today don't behave as nicely as the limits that we've been seeing before. So we've talked about the idea with a limit, like the two sides have to meet. If it's coming in from one way and the other way, they have to meet in the same direction. Now, one thing we're going to look at today is the one-sided limits where they don't equal a number. So they're both coming in the same direction, but they might go to infinity, like they just keep going straight down or they keep shooting straight up. So if a one-sided limit goes to infinity, then it's asymptotic, meaning that there is a vertical asymptote there where the graph is heading towards it, but it's just heading straight down, or it's heading straight up at that asymptote. And it can either be from the left or the right. What that value is, that C value inside of our limit, that is where our vertical asymptote is going to be. So if we take a look at this graph, we've got a vertical asymptote here at 2. So this limit, as x is approaching 2 from the right, is just shooting straight up. Look at this number. Look at how big this number gets as it gets closer and closer to 2 from the right. It just gets huge. So this thing is heading towards infinity. It's getting huge. You can see the same thing in this one, but we can check both sides. Now, they're not going to necessarily have to match in order to be an asymptote. This one shoots down and the other one shoots up, but that's okay. We still have that nice asymptote at -2. So as the graph is approaching -2 from the left, from the negative side, it's heading down to -infinity. And as it's approaching -2 from the right-hand side, it's shooting up towards positive infinity. If you'd like to look at that graph, again, there's the code down there, and it'll graph the whole thing for you. Or you can type it in yourself into Desmos. Now this one has two vertical asymptotes, one at -2 and one at +2. You could see those values if you factored this denominator, become an x plus 2 and x minus 2. So this blue one, and on the left-hand side, it's shooting up towards positive infinity. The other one's shooting down towards -infinity on the right-hand side. That's right here, it's coming down, but then it's also coming down here when it's coming in from the left on this +2. So this one is going towards -infinity and the other towards positive infinity. That's how we can see those asymptotes inside of those limits. Here's a couple more examples. They're just going towards infinity. So this one, -1 as it's approaching -1, which is right here. From the right, this thing's shooting straight up. Same thing with this inverse sign as we're approaching 0. From the right-hand side, this thing's shooting up. So much so, same thing over and over again. Now, these denominators equaling 0. So it seems to be that the denominator equaling 0, that's always our vertical asymptote. No, that's not the case. Check this example. We have, if we factored that denominator, we get 2x minus 1 and then an x plus 2. I grabbed my key just to make sure I was factoring this properly. I hate it when my videos aren't right. So let's see, we got 5, we got an x plus 2, and an x minus 2. Now, what's interesting is that these two pieces cancel each other out. Since those two pieces cancel each other out, when we simplify that rational expression, we don't end up with a vertical asymptote. Hi, Maleficent. Do you like vertical asymptotes? Oh, she loves them. Since those cancel out, we end up with just a hole in the graph rather than a vertical asymptote. Isn't that right, Maleficent? Oh, she loves it. However, that 2x minus 1, that one is giving us a vertical asymptote because it doesn't cancel out. And since it doesn't cancel out, we have a vertical asymptote there at A. At A, Maleficent. Right there. That sound good? She needs me to play with her. We're going to finish this video first and then we'll play. It's Saturday. Come on. So here's a couple more examples of that same fact happening. So here, those two things are not canceling each other out. Since they're not canceling each other out, we do end up with vertical asymptotes at those two spots. Now this one, which is not factorable, does not actually produce any vertical asymptotes because there is no real number that we can put in there in order to create that denominator equal to 0. Try it. You get 0 equals x squared plus 9, and you end up with x equaling plus or minus 3i. That's an imaginary answer, and there is no imaginary numbers on our xy coordinate plane. All of them are real numbers. If you went out into a third dimension off of your plane, then you could start seeing some of that stuff happening, but there's not going to be anything on our graph because there's nothing we can put into the denominator to make it 0. Can't make it 0, no vertical asymptotes, no holes in the graph. This last one is just kind of like a sneaky little trick question. So if it has a vertical asymptote, it's undefined. You can have vertical asymptotes, but you just got to fill in the graph. You just got to fill in that little spot with a 3. So we have a vertical asymptote here. This limit would approach infinity on one side and negative infinity on the other, but then you just fill it in with something, a 3, whatever you need. And I believe that is it for our asymptotes. So these ones are particularly good to go back to what we were doing initially with our functions. Is kind of like look about what's going on with their graph. Or you can also look for what is going to cancel each other out. So we're kind of looking at graphs again. So yeah, that's it. Nice short video. Yay! Have a good Saturday. Bye.